Hello everyone, New York Games here with another video in the tutorial series of remaking the core version of Getaway Shootout. In the last video, we got the spawn point system implemented, and this is just one use of that waypoint system that we have been creating. In this video today, we'll actually be focusing on another use of this waypoint system, and that is the computer movement. So the computer movement will be guided just based on all the waypoints we place in the level, always trying to reach the next waypoint. And I want to reiterate that this is just one way to do computer movement. It's the way that I originally did it in Getaway Shootout, but there's definitely plenty of other options, some that might be way more efficient or faster, more smart. So feel free to try out your own ways of making the player move around the level. But this is just going to be a nice way to quickly get computers moving around our level. So I'll actually hop over to the notepad and actually draw up the solution that we'll be implementing for the computer movement today. So say if we have just a simple level like this with one big platform in the middle, we'll be actually implementing two types of movement for the player. These will just be two simple movements that the player can get to the next waypoint. The first one, I'll call it the basic movement. And that will just be, if the waypoint is to the right of the player jumps to the right. And so forth, if the player is to the right of the waypoint, the player jumps to the left. So that is just a very simple movement that we can implement quickly in code. The other type of movement, and I'll get to details of when we want to use which one, is something I'll call a precise movement or precise jump. Is say if we have a waypoint here and our player's down here, we want to actually jump in the direction of that waypoint. So if that is the line to the waypoint from the player, we want to turn the player so they're orientated at the waypoint and then jump. And something like this would be very helpful in this ledge scenario, where if we have a waypoint nicely positioned right there, the player will actually jump toward that waypoint and actually follow through and end up on the ledge. So that's those two type of movements is basically how I do the whole Getaway Shootout computer movement system. And basically this second type of movement, the precise movement, is anything that involves a precise jump for parkour or getting over a ledge like this. And this first movement is any type of movement that the player is just getting to the next waypoint with no obstacles in the way. And the way we'll actually define when to use these two types of movement is to only do a precise jump when the player is a set amount of distance below the next waypoint. And I just have it like this because if the waypoint is a lot higher than the player, we most likely want to jump up to that waypoint. So this is going to involve a precise jump to get up to that ledge or to any obstacle. And we'll also add kind of a boundary to this precise jump. That way, if the player is way over on the left side of the map, we don't do this precise jump yet. We just default to the basic jump until we get into this zone here. I guess right here. So that's just the layout of the two types of movements we'll be implementing in the video today. So with that, I'm going to jump back to the project and we can actually get started on implementing this in code. The first thing I'll do is actually jump to the waypoint manager and I'll open it up. So this was the solution that we were implementing in previous videos. And we'll just have to add one new method and I'll add it down here. And the method that I want to create is basically the same as getting the current waypoint, but instead of the current waypoint, I actually want to get the next waypoint. and this will be used for the computer movement. And the way we'll do this is just have the current waypoint +1 to get the next one. But we also want to make sure that this doesn't go out of bounds on this waypoints array. So I'll just do math.min to make sure it never exceeds the bounds of the waypoint array. So waypoint.length, and since it's 0 index, we'll subtract 1 to make sure it never goes past the length of the array. So I'll save that, and now we have this method to get the next waypoint. The next thing I'll do is to actually create this new computer movement script. So if I jump to the player folder, the player scripts folder, we already have a player human controller script, and I think what I'll do is actually just create a player computer controller script. So it's the equivalent for the human script, just the computer one, and I'll call it player computer controller. The name is a little clunky. Maybe I'll change that in the future, but this is just basically going to be the script that controls the player by the computer. So this is where, we'll be implementing that. I'm actually going to leave it blank for right now because there's actually one thing I want to do before that. And I'll navigate over to the game manager because this is where actually I want to decide if I want to add the player human controller or this new player computer controller to our player object. So by default, we're just doing the player human controller to every player in the scene, but I want to add this player computer controller if the player is a computer. And the way I'm going to do this is going to create another variable up here, and I'm just going to create another integer, and I'm going to say this is going to be the number of human players. That way we know, I'll default it to 1. That way we know how many players that are going to be given human input in the scene and how many to assign that player human controller. So with this new variable, I'm just going to do that. Instead of looping through the number of players, I'm going to loop through the number of human players. And then when we're creating the players, I'm going to just simply check if I is less than number of human players. Simply add that human controller script. Otherwise, just add that player computer controller script. So that's how we are going to easily just differentiate the player and computer input system, just simply by adding a human controller or a computer controller when we're creating the player. So I'm going to save that, and that should be enough to actually be adding these computer controllers. And so now the next thing to do is actually just implement this class to actually control the player movement. So there's many options to actually implement something like this, where I said there's that 2 modes of jumping. One thing I'll do when implementing this is actually use something called coroutines, and I believe we actually used this in a previous video. This will just make it very nice to add wait times and waiting for the player to turn, and it'll just be really easy to implement in code. So that's what I'll start with. Could remove this, remove the comment, and I'll just create a new coroutine. It's called iEnumerator, and I'll call it the movement loop, just move loop. And this will basically be this loop that's looping forever, that is basically trying to get the player to that next waypoint. So a simple way of doing this would just be doing a while loop like this. So while true, this basically just means loop forever, always trying to get to the next waypoint. And the first thing I want to check is if the player is grounded. So, well, first we're going to actually need a reference to the player movement. So I'm going to say player movement up here. And I'll just call it PM. And then on start, we'll just do something like that. And we'll do PM dot is grounded. And actually, I think is grounded is not public. So let me jump to here. So I'm just going to make is grounded public so we can use it from this other script. So the first thing I want to do is call this method if we are grounded. And so this is going to be in the move loop. And I want to know if we're not grounded, don't bother try to move around because in our game, we can't turn if we're not grounded. So there's no point of trying to move around. So if we are not grounded, we want to basically wait some time to check again if we're grounded again. So I'm going to do something like yield. We'll do something actually, we'll continue. So continue just moves to the next iteration of this while loop. But before we do that, I'll do something like yield, return, new wait for seconds. And then this is going to be the amount of time to wait before we check if we're grounded again. So I'm going to do something like, we'll do something like a random.range. And I believe in the original Getaway Shootout, it's something like 0.5 to 1 second. And these values kind of change based on the computer difficulty, but we'll just do something like that for now. Okay, so we have this first part of the loop, checking if we're grounded. So if we get to here, computer is grounded, move to next waypoint. So the way we move in Getaway Shootout is by jumping. So I'm going to actually do something like jump here. And I haven't implemented this yet. But the last thing I want to do in this move loop is actually just to wait some more time. So this is after we jump. We basically just wait some more delay. That way we're not jumping super fast. And I believe in the original Getaway Shooter game, it was just a constant 0.2 seconds. And I'm trying to make it a little similar to the original Getaway Shootout game if you just want pretty identical computer movement. So that's something close to the actual game. So the last part that we need to do is actually implement this jump function. And I'll actually make this jump function another coroutine. So again, our numerator, and I'll call it jump loop. And the reason why I'm making this another coroutine is because this jump loop is actually going to be delayed. We're going to start turning, and then we're going to want to wait until the turning is reaches our desired angle to jump at. So I'm going to call it here. And so we're calling a chain of coroutines, and this is actually all fine in C#. I believe the syntax to call it within coroutine is something like this. We'll just need to double check, but basically this is saying execute this coroutine and wait until it's finished executing, and then move on and go to the rest of the code, which would just be repeating this while loop. So yeah, we'll continue forward with that. And with this jump loop, it's just going to be a pretty simple function. The first thing that we want to do is to actually get the angle that we want to jump at. And this is actually going to be a little bit more involved because this is the whole logic of either doing a precise jump or a basic jump. But for right now, I'll do something like this, jump angle. I'll set it to 0 for now. The other angle that we want is our current body's angle. And I'll do that, so something like body angle. And I did move it around a little before this video, but if we get our player's body, so private player body, and this is a script I kind of made off scene, not in these videos, but this script is just associated with all the kind of values of our player ragdoll, that player prefab. So in this body, I moved that, here, let me just jump to it. We have that get rotation that I moved it from the player movement into here, and this just gets the rotation of the player body. So I'm just gonna call this function. So body.get rotation. And this is nice because this get rotation is, I believe, let's see, it is a value between 180 and, negative 180 and 180. And it's in respect to the vertical axis, which is what we want when moving and turning the player. So I'll just get the rotation like that. And the last thing now we want to do is basically to determine, we have our jump angle and we have our current body's angle. We wanted to know which direction to actually turn the player now. So I'm going to do something like bool, turn right. And this is simply just comparing these two angles. So if our body's angle, body angle is greater than jump angle, let's see, body's angle is greater than jump angle, we want to turn left. So actually I'm going to do something like this. Jump angle is greater than body angle, and that should be now right. So if our jump angle is to the right of the body angle, this will be true. Otherwise, this will be false. So the next thing that we'll implement in this jump loop is to actually, first start turning. So I'm going to do start turn. And our start turn has a Boolean, turn right, and we just pass in that bool that we created. Now, all we have to do is to wait for the computer movement to reach that desired turn angle. So we have the desired turn angle right there. And what we'll do is something like a while loop. So while, we'll do while body.get rotation to get the current rotation. And I'll just do the case of the turning right condition. So while body.get rotation is less than the jump angle, we basically then want to, while it's to the left, we basically just want to continue looping and waiting while the player turns. So all we have to do for that is just to wait for the next frame. And since this is kind of involved with the physics update, I'm actually going to do this only on physics move. So that's the fix update. So I'm going to yield, return, new, wait for, and I believe there is a fixed update. Yeah. So I'm just going to basically have this loop check every fix update. And now this doesn't fully work because if we're turning left, this condition will actually exit right away. And an easy way to do this is just with Boolean logic. So if we do something like equals turn right, and again, this is like a Boolean logic thing where if we're turning left, we're just checking when this condition is false. That's when it'll continue looping. And before this turn right is just the same thing as not even having it. So that's just an easy way to kind of check the two conditions, right and left, in just one line. You could write it out in 2 lines if it's simpler that way. And then at this point, we have waited for the player to jump or to turn to the correct rotation. Last thing we want to do is actually just jump the player. And again, we need to just pass in the jump right if we're jumping to the right or left. And this was just simply the direction that we were turning in. So that is our jump loop implemented. The last thing we need to do with this method is to actually implement this desired jump angle. So I'm going to create a new method down here. I'm going to say get jump angle. And this is going to be the method corresponding to get the actual jump angle. So I'm going to call it like this and something like that. Okay, so to implement this jump angle, we're going to be doing those 2 types of jumping that I mentioned at the beginning of the video. And we'll cover the precise jump in the first case. So as I was mentioning, we want to only have the precise jump in a certain zone. And that's if the difference of the x component is within a certain range. So the first thing I'm going to do is actually get that difference. So I'm going to do something like vector2 difference. And we want to basically get the difference between the player and the current waypoint, or the next waypoint. And I'll actually pass in the waypoint, make it something like this. And so up here, when we're getting this jump angle, we'll actually get the waypoint, and we need a reference to the waypoint manager when we're doing this. So I'm going to jump up all the way up to here, and I'll create a reference to waypoint manager, something like WM. And for now, I'm just going to do something like find first object by type waypoint manager. But again, this is a little expensive, and in the future it could be something just assigned maybe by the game manager or from some reference, but for right now it's could be fine just to do this, and that basically just gets the access to the waypoint manager. And we'll just do the simple method of getting the next waypoint, which we just implemented at the beginning of the video. And again, we have the key, which is our navigator that we want to get the waypoint for, and that just could be our own transform, since this component is on the same transform as our player. And we'll just pass in now the waypoint to this function here. So with the waypoint passed in, we can simply get a difference by doing something like this. Basically subtracting the waypoint position minus our position. And I'll actually make this, I was going to make it a vector 2, but I guess it automatically gets converted. And now this is where we want to do the check of if the difference and the x component, and I'll actually do math.abs. And we want to check if this is in some certain range of doing that precise jump movement. So I'll actually create a variable up top here, and we'll just leave it here for now, I guess. And this is just gonna be a float, and this will be our constant of when to do a precise jump. So I'm gonna do something like precise jump X range. And I believe in the original Getaway Shootout game, it's something like 5. So if we're within 5 units of this waypoint, and while we're here, I'll also do another float, and it'll be the precise jump Y range. And this is going to be a value of 1.5. And maybe this isn't a great name for the Y, because this is more if we're out of the range. So if we're like below the waypoint by 1.5 units, then we also do the precise jump. So maybe that's not the best name, but I'm not sure what else could be a better name for it now. And also, since this is a constant, I believe if we assign it something like this, since that these values are not going to be changing, we can just do that. And now we simply use these variables that we created. So I'm going to do something like this. When the difference of x is less than that x jump range, and the difference dot y, well, we want to check again if it's less than that precise y range, but we only want to really check if it's below the waypoint. Since it really doesn't make sense to be jumping precise when it's above the waypoint, it'd be like jumping through the ground. So this would mean that when the difference dot y is less than negative, and then actually, no, hold on. It'll be something like this. When the difference dot y, so when there's a y difference that is greater than this precise jump range. Now this is the zone that we want to do this precise jump. And again, this is kind of just arbitrary. This was something I decided just in code in the original Getaway Shootout game, but it works out pretty nice. So that's what we'll be doing. And now to get the precise jump, we need to actually get the angle from the player to the waypoint, and that's just through trigonometry. So we're going to do something like float angle equals math.atan2. So this is the inverse tangent function. And basically you pass in the coordinates of the difference. This is basically like the triangle if you're creating a mental image. And so this will give us the angle. We also have to convert it to degrees. And one other small change we'll have to do to this is actually to rotate it by 90 degrees, because just from trigonometry, this angle will be, the zero angle will be on the horizontal axis to the right. We want it again to be the vertical axis is the zero angle, basically the up direction. So the way we do that, we'll just rotate it by 90 degrees, which is just subtracting. And yeah, so this is actually just the angle that we want to jump at. So we can actually just return this angle. One thing I'll do before returning it though is actually to clamp it. So I'll do something like clamp. And this clamp function just makes sure that this value stays in between the two specified ranges. And the ranges I want to just be inside is actually just the player movement. We defined a max turn angle here. So we just don't want this, the angle that we return to ever be greater than that, because we can never reach that. So I'm going to do something like PM max turn angle. And I'll just give it a little leadway or a little room. That way it is not exactly that. We could get into a case where it's still trying to turn, and since it's exactly, there's like some floating point error, or something like that. I think it's just safe to just give it a small little room for air. Basically, it's not turning all the way. And I'll do the same for the max. And obviously, we want this one to be the negative, so I'm going to do something like that. So we're keeping the angle between this minimum and maximum. Okay, so that's actually pretty simple to implement. That's the precise jump, and maybe I'll just give a comment here. Otherwise, we want to do the basic jump that I was mentioning at the beginning of the video. So otherwise, and for this, it'll actually be pretty simple. We just want to turn in the direction, or jump in the direction where the waypoint is, and we can get the direction by getting the x component of the difference. And basically, we can convert this into a bool, something like turn right, or let's say like jump right. And if this difference is greater than 0, well, we obviously want to jump to the right since the waypoint's to the right. And then this will be false if we want to jump to the left. So that is that. And the final thing I want to do is actually, well, return the angle. So we'll do something like, well, for right now we can return just a constant angle of 50 degrees. So we just basically just jump to the max. Actually, we can do something like max turn angle. Just turn to the max turn angle, maybe subtract a degree or so. But we need to multiply it by the direction. And I'm just realizing maybe bool is not the right way to go. Maybe do something like jump, and I'll say jump direction. And we'll use the operator here to basically, if the jump direction is to the right, we'll say multiply by 1, otherwise multiply by -1. That way we can easily do something like this, where we're just multiplying this whole expression by the jump direction. And that will give us the actual correct turn angle. And that seems like all we need to implement for this basic jump. But looking at the original code, I'll make it a little similar to the original code. And there's actually a slight difference, and that is actually 20% of the times, this is just some arbitrary number, 20% of the times I actually do a short jump, and that's basically where the player jumps basically upwards. And this is just random, so we do something like bool, jump short. And to do something 20% of the time, we can do something like random.range. And if I do something like 0 to 5, this will give us a number between 0 inclusive to 4. And we can just check if this equals to 0. So that'd be 20% of the times we're jumping short. And we can do something like this here. So if we are jumping short, return something very close to the 0 degree angle. Let me see what, in the actual code, we do something like random.range. And this is a value of like 6 to 22.5. I'm just copying the actual values here. And so that's only for jumping short. Do something like this. Obviously, we want to times it by the direction. Something like that. Oh, jump direction. And then otherwise, we want to do the long jump, which is a jump very close to this max turn angle. And I guess in the actual, I'll give the actual values that I do in the Getaway Shootout. So this was something like random.range and 28 to 48 degrees. And these again, just chosen by random. You can change this to however you want. And you just have to make sure if you set max turn angle to something below this, you don't have to update this in code. But I'm just going to leave these as the actual Getaway Shootout code constants for right now. And so yeah, that should be the whole implemented jump angle. So we return the angle that we want to jump at, and then we actually turn to jump at that angle and jump. And we're always just continuing to repeat this jump every time. Okay, so that all seems right. We'll actually test this, but before we test it, we have to call this move loop. And basically you need to start the coroutine to actually get this running. So at the beginning of the game, actually we probably want to do something like on enable, since could be, this whole game object could be becoming active and unactive. So I'm going to do this every time we enable this game object. We want to start the coroutine called move loop. Okay, so that should kick off the movement, and the player should start executing this logic. I think the last thing to do now is to actually test this. I believe if we just jump to the game, first thing I'm going to do, we'll keep it so there will be one human player, that'll be us, and then we'll also, since there's a max 2, there'll be one computer player. Now let's check if this is actually executing code. So if I click play, hopefully we see, okay, we got an error. Let's see what the error is. So it's saying there's a null reference. Oh wait, it's not error. There it is. Okay. So it's saying there's something. Oh, okay. We do set the player movement. For some reason, the player movement is not getting set. Let me check when I click create game. If this becomes too long, I'll just pause the video. But if we go to here, we can see player movement is on this game object. And we have the player controller script. If I go to debug mode, not everything's set. I'll actually just pause this for right now. Oh, wait, now, hold on. Let me go back. Wait, where was I? Okay, player control. Okay, so I think I know what's wrong. So we're calling this on enable. Start actually calls after on enable, I believe. So if we turn this into awake, I believe that's the right order of execution. Basically, awake calls before on enable, but again, start, I believe, calls after. So let's check that. Okay, so player seems to start turning, but now it's stuck turning. Okay. Maybe I'll just actually pause this since it might take a while. Okay, I think I have figured out kind of what the issue of the problem will be. So if I jump to the game quick and click play, I was thinking that turning right would actually increase the rotation, but how the way rotation is set up, this is just the same as how rotation is defined in math. Turning clockwise will actually decrease the rotation, and turning counterclockwise, so turning to the left, actually increases the rotation. So I think I had everything kind of just swapped or mixed up, and basically we'll have to just kind of invert it to be the other way. So we only want to turn right when the jump angle is less than the body angle. In other words, I feel like just having body angle first, just the way I think about it. So if the body angle is greater than the jump angle, then we want to turn right. So basically, this is saying, yeah, I think that works. And then we'll want to update this function down here. So again, well, the body angle is greater than the jump angle, we want to continue turning. So basically we just have this check just repeated every frame until we reach that desired turn angle. And again, there's just that Boolean logic to make sure it is checking for the turn left condition as well. And now, so this get jump angle will have to change just a bit. So I think the precise jump is fine, but for doing just a basic jump, we want to actually invert this. So if we're wanting to jump to the right, again, jumping right is negative angles, and jumping to the left is positive angle. And that's all I think we should do to make it work. So let's check. Okay, so the player's jumping to the right. Player's kind of getting stuck there. It's hard to tell exactly what it's doing. Oh, okay, I moved it upwards. Seems to be doing fine, and once it gets to that last waypoint, it's just going to jump back and forth between that last waypoint. Yeah, I mean, that seems fine. Let me check again, because it kind of got stuck at that cube at the start. And I don't know if that is an issue with our code or if it's just an issue with that collision. Let me quick jump over this. I'm just going to debug basically this jump angle. So I just want to know what angle that we are targeting. So jump angle. Because that movement seems a little different than the original Getaway short game. I don't remember. So it's targeting a large angle like this, but it is getting stuck. It's almost like it's not jumping. I think I'll pause it again. I could just debug this live here. I guess let me know in the comments if you would like me to not pause. But for an issue like this, I'm just gonna debug some more lines and we'll see if I can get an error to what we're seeing. Okay, so I have debugged some things just to check what's going on. But after debugging, I think it's actually working as expected. It's just because something like this just shows kind of how buggy, or not buggy, but how sensitive the system can be to these waypoints. So it actually does seem to be doing the actual code, or actually like getting to the next waypoint as we specified. It's currently how we have these waypoints set up though, is not good for the player to actually get to the end point. Because as you can see, the player is trying to do a precise jump to that right here, and it's getting stuck at this wall. So this was to the beginning of the video where we want to place these waypoints at precise locations, and since the player is now targeting this waypoint now, it's still jumping at the wall. So if I move the vertical zone to something like this, now the player is going to be targeting this waypoint, and it's going to do a precise jump to try to reach that waypoint. But yeah, this is where this kind of system gets a little fiddly, because now we have to somehow optimize the player to make sure it jumps right at the right angle to actually jump through that and get to the ledge. And this actually, I spent a decent amount of time when developing the original Getaway Shootout maps to make sure these waypoints were set up correctly, to basically get the player to jump as efficient and as fast as possible to the waypoints. And I guess before, when we were seeing the bug that is hitting this cube, and that seems actually normal, because basically it's just hitting the cube, trying to get to this waypoint up here, and it's probably just doing a basic jump to the right, so it's just spamming that way. So I think that is correct. So the last part of this video, actually, I want to just try to set up these waypoints the best I can to actually get this computer movement to the end. And yeah, you'll see the process of setting up these waypoints like I did in the original game. So let me jump to the template map. And I believe this jump here, this ledge, is actually too high for one jump. So we're going to need the computer player, to jump on this platform right here, and then to that platform. And again, yeah, this is where it can kind of get a little fiddly to get the player to do exactly what we want. But what I'll do for this is first create a waypoint. Well, let's see. So we want the player to be jumping to this box. So if the player is right here, we want the waypoint to be something like here. So it jumps up and then lands somewhere roughly on the box. Same thing if they're here. Hopefully they do something like this. This will be just something that we have to guess and check. But the thing I'll actually make sure to have is have this vertical zone to be up, because we don't want to trigger the next waypoint when we're somewhere below here. And I'll make sure to actually decrease it to something like this. And this is the whole point of the zone offset. I can keep that direction where the player wants to jump at, but change the zone of where the next waypoint gets activated. And so let's see, think about this a little more. Actually, I'll test this out. I'll go something like this and have the zone just when that player's on the box like that, to actually then trigger the next waypoint. And the next waypoint, I'll do something up here. So we want the player to jump from the box to the direction of this waypoint, and hopefully get on that ledge. So let me do something like this, and I'll do the X direction, something like that. Okay, so now we should be able to test this out. And then maybe I'll just create one more waypoint, just be completely right, and have it set down here. It's nice just to have these waypoints, because if this waypoint, if it got below and then somehow got to the next waypoint, it would actually reset to the previous waypoint. And that's actually the cause of many bugs, is when before going to the next waypoint, it gets out and then resets, which was the cause of many bugs in the original Getaway show game. Okay, so now I'm going to click play, and I'm going to actually see if a waypoint system like this, if this is better for the player movement. Okay, so the player just randomly got to that box right away. It almost works. Okay, so it's jumping to that. So maybe this should be a little to the right, but in that case it worked. Let's see if it... respawns. Actually, that one worked straight off the bat. So there's a decent amount of randomness involved with this system, since we are having different delays with the random wait times and so forth. I'm just gonna make this one spawnable as well, because I just want to check when the player gets up here, can they get across the bridge? So again, so the waypoints actually seem pretty good set up already. Player gets across, and player keeps jumping. Okay, so that seems to be decently set up. And obviously, once it gets to the last waypoint, it's just going to jump around that last waypoint. But yeah, you can clearly see a solution like this definitely has limitations. Obviously, a little fiddly to set that up, and you can unexpectedly get cases where players not going to the correct waypoint, or the waypoints get reset. So if you have suggestions in the comments of ideas for different player or computer movements, yeah, feel free to suggest them, and yeah, definitely try out if you have other ideas. Also, yeah, one case in particular, a case like this bridge or this gap here, the current system is pretty dumb, where it's just going to jump to the right and it doesn't even know about this gap. So, and this actually works out in the original Getaway Shootout game. You just don't really notice it that much, hopefully, because it looks pretty normal to just keep jumping to the right, even though a better jump would actually be precisely to here and then off. But again, if you want to make the system more sophisticated, by all means, try it out. So that's where I'll be stopping the video today. We got a pretty basic computer movement implemented to the game, which is actually basically the exact same as the Getaway Shootout version. And the next video we'll finish out with the computer input system, and basically all we need to do left with that is the player power up for the computer and when to activate that. And yeah, so that would wrap up the computer input. And yeah, I'll see you in the next video where we'll implement that. Thank you.